Have you ever stood in complete silence and felt like you could hear something? A faint hum, a distant ringing? What if I told you that the universe itself is humming, vibrating, and singing a song on a scale so vast we only just beginning to learn how to listen? Close your eyes for a moment. Forget the traffic, the notifications, the noise of daily life. Imagine floating in the absolute stillness of space. What do you hear? You might think, nothing, but that couldn't be further from the truth. The cosmos is a symphony of sound, a celestial orchestra that's been playing since the dawn of time. Let's start with the very first note of this cosmic song. It's a sound that fills every corner of the universe, a relic from its birth. It's the cosmic microwave background, or CMB. Think of it as the afterglow of the Big Bang. About 380,000 years after the universe began, it had cooled enough for the first atoms to form. This moment, called recombination, released a colossal burst of light. For billions of years, this light has been traveling across the expanding universe, its wavelength stretching out until it's no longer visible light, but microwaves. But here's the amazing part. This ancient light isn't perfectly uniform. It has tiny temperature fluctuations, like ripples on a pond. Scientists at places like NASA and the European Space Agency have created detailed maps of these ripples. And what happens when you convert these temperature fluctuations into sound waves? You get a sound. It's a deep, resonant hum, the universe's oldest lullaby. If we were to scale it up to a frequency we could hear, it would sound like a deep, persistent buzz. This isn't just background noise. It's the echo of creation itself. It's the universe, as a baby, gurgling its first sounds. It tells us about the universe's age, its composition, and the very seeds from which galaxies would one day grow. We are literally hearing the sound of the beginning of everything. Now, let's fast forward a few hundred million years. The universe is no longer a uniform soup. Gravity has been hard at work, pulling matter together. Stars are igniting, galaxies are forming, and the orchestra is getting a new section, the percussion. I'm talking about gravitational waves. Albert Einstein predicted them over a century ago, but it wasn't until 2015 that the LIGO Observatory made the first direct detection. These are ripples in the very fabric of space-time, caused by the most catastrophic events in the cosmos. Imagine two massive black holes, each many times the mass of our sun, spiraling towards each other in a deadly cosmic dance. As they get closer, they whip around each other at nearly the speed of light, warping space-time around them like a bowling ball on a trampoline. In the final fraction of a second, they collide and merge, releasing an amount of energy so immense it's almost unimaginable. This cataclysm sends a powerful shockwave rippling through space-time. This is a gravitational wave. When scientists convert the signal from these waves into sound, it's a chirp, a sound that rapidly rises in pitch and volume before abruptly stopping. It's the sound of two black holes becoming one. Every time LIGO or Virgo detects one of these chirps, it's like a cosmic drumbeat announcing the collision of titans. We've heard the sounds of colliding neutron stars, too, a different kind of chirp that helps us understand how heavy elements like gold and platinum are forged. These aren't just sounds. They're bulletins from the universe's most extreme environments, telling us stories of cosmic violence and creation that we could never witness with light alone. But the universe's symphony isn't just about the big, loud events. There's a subtle, ongoing rhythm, a low-frequency hum that pervades everything. For decades, astronomers have been using pulsars, the incredibly precise, spinning remnants of dead stars, as a cosmic timing array. They are like a network of celestial clocks scattered across our galaxy. Recently, the North American Nanohertz Observatory for Gravitational Waves, or NANOGRAPH, announced something groundbreaking. After 15 years of listening to these pulsar clocks, they detected a slight deviation in their timing. It's as if all the clocks were subtly speeding up and slowing down in a synchronized way. The culprit? A background hum of low-frequency gravitational waves. What's making this hum? The leading theory is the combined chorus of supermassive black holes. We're talking about the behemoths that sit at the center of nearly every galaxy, millions or even billions of times the mass of our sun. Across the universe, countless pairs of these giants are slowly spiraling into each other as their host galaxies merge. Each pair is too far away and moving too slowly for us to hear individually, but together, Their gravitational waves blend into a constant, stochastic background noise. It's like being in a crowded room where you can't pick out a single conversation, but you can hear the overall murmur of the crowd. We are hearing the collective sound of galaxies dancing and merging across cosmic history. So we have the ancient hum of the Big Bang, the violent chirps of colliding black holes, and the background murmur of galactic mergers. But what about our own stellar neighborhood? Even our own sun is a musician. Our sun isn't a silent ball of fire. It's a churning, bubbling mass of plasma, with massive convection cells of hot gas rising and falling. These movements cause the entire sun to vibrate, to ring like a giant bell. This field of study is called helioseismology. By studying the subtle oscillations on the sun's surface, scientists can map out its interior, much like how seismologists use earthquakes to understand the Earth's core. These solar vibrations are at incredibly low frequencies, far below human hearing. But if we sped them up millions of times, we would hear a complex, resonant sound, a low, pulsating hum with layers of higher-pitched ringing tones. This is the sun's song, and it tells us everything about its internal structure, its rotation, and the dynamics of its magnetic fields. Every star in the sky is likely singing its own unique song, a field known as astroseismology. We're learning to listen to the stars themselves. And the music doesn't stop there. Planets with magnetic fields, like Earth and Jupiter, create their own brand of cosmic audio. Charged particles from the sun, the solar wind, get trapped in these magnetic fields and spiral around, generating powerful radio waves. When converted to audio, these are some of the spookiest, most otherworldly sounds you can imagine. They're called whistlers, spherics, and chorus emissions. They sound like eerie chirps, strange whistles, and the sound of a flock of birds at dawn. This is the sound of the Earth's own magnetic shield protecting us, a constant conversation between our planet and our star. From the macrocosm to the microcosm, let's zoom all the way down, past atoms, to the quantum realm. At this fundamental level, reality isn't solid. It's a jittery, probabilistic dance of particles and fields. Quantum field theory tells us that even in a perfect vacuum, there's what's called quantum foam. Pairs of virtual particles pop in and out of existence for fleeting moments. This isn't silence. It's a subtle, underlying hiss of reality itself. Moreover, string theory, a leading candidate for a theory of everything, proposes that the fundamental constituents of the universe aren't point-like particles, but tiny, one-dimensional vibrating strings. Each mode of vibration corresponds to a different particle. An electron is a string vibrating one way. A photon is a string vibrating another way. In this view, the entire universe, with all its matter and forces, is nothing more than a grand cosmic symphony, played out on an orchestra of these infinitesimal strings. The laws of physics are the rules of harmony. So, what is the universe telling us with all this noise, this symphony of creation? It's telling us its story. The CMB is its birth announcement. The gravitational wave chirps are dispatches from its most dramatic moments. The low hum of supermassive black holes is the sound of its evolution, of galaxies growing and merging. The song of the stars is a window into their hearts. And the quantum vibrations are the very music of existence. We've spent most of human history just looking at the universe. But now, we're learning to listen. And just as adding a soundtrack transforms a silent film, this new acoustic dimension is revolutionizing our understanding of the cosmos. It's revealing events that are invisible to our telescopes and confirming theories that once seemed like pure science fiction. The universe isn't a silent, empty void. It's a vibrant, dynamic, and very noisy place. It's singing a song of its past, its present, and its future. We are the audience, living inside the concert hall, and we've only just tuned our instruments to begin hearing the music. The next time you find a moment of quiet, listen closely. You might just hear a faint echo of that cosmic symphony. Thank you so much for joining me on this auditory journey through the cosmos. If you found this as fascinating as I do, please hit that like button and subscribe for more deep dives into the wonders of our universe. What cosmic sound do you find most incredible? Let me know in the comments below. Until next time, keep looking up and keep listening.